أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على رسول الله وعلى آله وصحبه وسلم. Hello students, today we shall continue on magnetism. Our topic for today is magnetic field. Magnetic field. Magnetic field is a region or space around a magnet where its magnetic force is exerted on magnetic materials. When you place a bar magnet on a table and you move some iron nails or pins towards the magnet, there will be a certain point, a certain distance at which the magnet will pick the pin or the nail. If you remove the nail or the pin from the magnet and you move it further away from the magnet, there will be a particular point where the pin will not be attracted by the magnet. So if you keep on moving the pin towards the magnet from a far distance and you observe whether the magnet is going to pick the pin, the magnet may not pick the pin, may not attract the pin until you move close to the magnet to a certain distance. Now the distance around the magnet, where the magnet is able to attract the magnetic material falls within the magnetic field of the magnet. So any magnetic material placed within the magnetic field of that magnet will be attracted by the magnet. So if the material is outside the field of the magnet, it will not attract such a material. So a magnet will attract a magnetic material if the material is within its magnetic field. But if it is outside the magnetic field, it will not attract that magnetic material. So you can demonstrate it. Take a magnet, move iron pin or iron nail towards the magnet. There will be a particular distance from the magnet at which the magnet will attract the pin, and there will be some distance or a distance where the magnet will not be able to pick the pin. So once the pin is able or is within the magnetic field, it will be attracted by the magnet. So if the magnetic material is moved further away from the magnet such that it is outside the magnetic field, such a material will not be attracted by the magnet. Line of force. Line of force. A line of force is the path taken by a unit north pole placed in the magnetic field. During the last class, we talked about the dipole that are present in magnetic materials, and we said that the dipole in a magnet have been arranged in such a way that all the north points in one direction, all the south points in one direction, and it forms a magnet, and it forms two poles, the north pole and the south pole. When you now take a unit north pole from a dipole, just remove the north pole from the dipole and place it in a magnetic field. That unit north pole will move away from the north of the magnetic field towards the south of the magnetic field, and it's going to form a particular path. So a line of force, that particular path is referred to as a line of force. So it is the path taken by a unit north pole placed in the magnetic field. A unit north pole in the magnetic field will move away from the north pole towards the south pole. So we use magnetic lines of force to represent magnetic field. We are going to draw several lines moving from the north towards the south of the magnetic field, and each line represents a magnetic line of force, and each line is the path that will be taken by a unit north pole when it is placed in the magnetic field. The magnetic field around a bar magnet is represented using lines of force. As you can see in this diagram, the bar magnet is represented by that rectangular structure labeled as NS. That is, N stands for the north, and S stands for south. So you see the direction. When you draw magnetic line of force, or you draw magnetic field, or you draw magnetic flux, you have to show the direction of movement of the north, of a unit north pole in that field. If you draw magnetic field of any magnet and you do not indicate the direction, you have not drawn anything. Just like if you draw rays of light, if you don't indicate the direction, you have not drawn anything. So when you are asked to draw the field around a bar magnet, magnetic field around a bar magnet, you show the path emanating from the north, moving towards the south. As you can see, if the line is drawn perpendicular to the north, it moves straight away from the north. Just move straight away. Because it will be attracted in both directions. So it will now move straight. And if it is drawn, if the line of force is straight, it's perpendicular to the south, it's coming straight to enter the south pole. It will not be deviated either to the right or to the left. Now you see other lines moving. So you see the lines moving out from the north and moving towards the southern direction, coming out of the north and entering in the south. That is how a magnetic field looks like, and that is the direction of motion of the north pole in the field. So that is how to draw the magnetic field. When you now draw the magnetic field of just a north pole, just draw a north pole and you draw the magnetic. You see the lines are coming out straight from the north, and you see the arrow shows that the lines are moving away from the north, as you can see. So if you are asked to draw the magnetic field around a north pole, this is the way to represent it. So a north pole, you see the magnetic field lines of force coming out of the north pole in different directions, moving out from the north in different directions. When you draw the magnetic field around the south pole, you see the lines coming into the south from different directions towards the particular south pole, as you can see in this diagram. So when you are asked to draw magnetic field around the south pole, this is what you draw. You draw straight lines coming into the south pole, and that is magnetic field around the south pole. Now, when you now have two magnets, you move opposite poles of two magnets towards each other, that is unlike pole. As we have earlier explained, that unlike poles attract. That is, the north pole of a magnet will attract the south pole of another magnet. When you draw the line of force, the field of unlike poles, this is how it looks like. Each line of force comes out of the north and enters the south of the other magnet. Each line comes out of the north and enters into the south of the other magnet. That is, they are attracting each other. They are attracting each other. When you draw the magnetic field of two like poles, if the two poles are north poles, you see they will repel each other. Each of them has its magnetic lines of force coming out of the north, but they will not enter into the north of the other magnet because they are like poles. They will repel each other and they move in different directions. It's as if they are going to move parallel. Yes, they move parallel to each other. They will never meet. They will never meet. They will move parallel. As you move the magnet towards each other, you are going to feel that repulsion force in your hand. As you try to force the magnet towards each other, the magnet will be moving apart and you are going to be feeling a force opposing your hand, opposing the force with which you are moving them together. So, because of the repulsion, and the lines are repelled away from each other and they move parallel to each other. Also, when you have south poles, they are also like poles, but they are south poles. Both of them are south poles of different magnets. South poles of different magnets will look like this. The lines are entering through the south as we have explained, but they will not enter or come out from one magnet and enter the other magnet. Each of them has its own lines of force coming into it, and they will also repel each other. So they will now appear parallel. The lines of force of one magnet will appear parallel to the lines of force of the other magnet. So this is another magnetic field of two like poles, but in this case they are south poles. So this is a convenient point for us to stop for today. We shall continue during the next class. Subhanaka Allahumma bihamdik, ashhadu an la ilaha illa ant, astaghfiruka wa atubu ilayk.